Hi, in this video, I'm going to discuss about the cell injury, and first we will know about the most common organelle affected during cell injury are the mitochondria, endoplasmic reticulum, nucleus, and the plasma membrane. Causes of cell injury are the hypoxia, which is most common, physical agents like heat and cold, chemical agents, infectious agents like bacteria, fungi, genetic agents, immunological agents like autoimmune disorders, and the nutritional imbalances, obesity, deficiency of protein, etc. Cell injury may lead to adaptation, reversible cell injury, irreversible cell injury, intracellular accumulation, and also pathogenic calcification. But I will only discuss about the adaptations, reversible cell injury, irreversible cell injury. Types of adaptations like hypertrophy, hyperplasia, metaplasia, and the atrophy. Hypertrophy means cell size is increased but no increase in cell number, and it's due to the increased synthesis of cellular protein. And physiological examples like skeletal muscle in bodybuilding, cell size will increase, and pathological hypertrophy like valvular heart disease, where the left ventricular hypertrophy we will able to see. And here in this image you will see normal cell, healthy cells, and the hypertrophy cell whose cell size is increased. Hyperplasia, which means increased cell number, which leads to increase in size of the organ because of the dividing cells of proliferating mature cells. And examples, physiological examples like after partial hepatectomy, liver will regenerate, and pathological hyperplasia like estrogen, which leads to the endometrial hyperplasia. Further, it lead to endometrial cancer also. Atrophy means decreased cell number, which leads to decreased size of the organ, and due to the reason of decreased protein synthesis or due to increased protein degradations. And physiological examples like thymus atrophy, also notochord atrophy, and pathological atrophy is due to senile atrophy due to age, and also we'll able to see disuse atrophy, pressure atrophy also. Metaplasia, in this case, we will able to see irreversible change in which one differentiated cell type convert to another cell type because of the reason of reprogramming of stem cells. And examples in smoker we will able to see pseudostatic ciliated columnar epithelium of respiratory tract converting to stratified squamous epithelium. And another example is like Barrett esophagus, where stratified squamous epithelium of esophagus converted to columnar epithelium on exposure to GERD, which is gastroesophageal reflux disease. And here in this image you will able to see normal cell is converted to metaplasia cell. Mechanism of cell injury: there will be mitochondrial damage, entry of the calcium, membrane damage, or due to protein misfold DNA damage. In case of mitochondrial damage, we will be able to see there will decrease ATP, which further cause multiple downstream effects, and increase reactive oxygen species cause damage to lipid protein DNA. And in case of increase calcium entry, it leads to mitochondrial permeability also increase, which further leads to activation of multiple cellular enzymes. And membrane damage like plasma membrane or lysosomal membrane damage. In case of plasma membrane damage, there will be loss of cellular component, and in case of lysosomal membrane damage, there will be enzymatic digestion of cellular component. And in the case of protein misfold DNA damage, we'll be able to see activation of pro-apoptotic proteins. In case of reversible cell injury, the injury in which the cell can go back to its normal state once the stimuli for injury is removed. Most common organelle affected is mitochondria, and in case of reversible cell injury, there will be swelling or hydropic change, which means leading to influx of sodium and H2O. and efflux of potassium, which cause cell swelling, and clumping of nuclear chromatin is due to increased amount of lactic acids, and last is the decreased protein synthesis and increased lipid synthesis due to detachment of ribosome from the rough endoplasmic reticulum. Irreversible cell injury, which also means cell death, is in the case when cell cannot get back to its normal state even if the stimuli for injury is removed. And this is the reason there will be mitochondrial damage, plasma membrane dysfunction. Nuclear changes occur in cell death like pyknosis, means clumping of the nuclear chromatin, karyoexis means fragmentation of nuclear chromatin, karyolysis means dissolution of nuclear chromatin. Below is the diagram where in the last case they will be able to see nuclear changes result all of these: pyknosis, karyolysis and karyoexis. That's all about the cell injury and the cell death.